in.
I'm there.
Is Gordon on?
Let's see here.
I see Rachel. I feel like Mr. Rogers in my Zoom meeting. And I see so-and-so and
Director Pace.
Mrs. Rogers.
there you go.
There's Ed.
I just want to make sure we have a quorum.
Let's see.
I'm not sure we really need to have a quorum for this
Okay.
because it's a workshop, right?
Oh, you're right. You're right. Great. All right. Let's get started then. All right. You've been hearing me babble on. We can start recording. Hello, my name is Kelly Long. I'm your Ventura County Supervisor and Board Chair for the GSA, Fillmore Piru Groundwater Sustainable Agency. Thank you all for attending tonight's workshop. We have been having multiple workshops in regards to different items pertaining to the GSA. And I would like to make sure when we're going through these items and you have a question or we get it. And then we'll also provide opportunity in regards to raising if you can go to your participant name and raise a hand, we'll be able to do some question and answering as well. Let's see what else. So I will introduce myself and then I'm going to ask Ed McFadden, our vice chair, to just go around some of the introductions. And Ed.
Hi, I'm Ed McFadden. Proud to serve on this board with everyone else. Let's see, I can't see everyone who's here, so I'm going to go through the list. I'm here, Kelly's here. Let's see, I see Dan Detmer's here from United, of course, Tony Emmerich, Lisa Balin. Let's see, Director Glenn Pace, say hi. Or not?
Hello, from Glenn Pace from the Piru Pumpers Association.
Okay, and let's see. I don't see Candace yet. Candace,
Candace is there.
I'm here, Candace
Candace is
Minigan
here.
with Friends of the Santa Clara River, representing environmental stakeholders.
Thank you, Candace. I'm scrolling through the list here. All right, is board member Gordon Kimball with us tonight yet? Okay, and I see we have lots of other people online. I'm glad to have everyone here, and why don't we jump right into this? Tony, are you starting up here?
Yes, I am.
Do you want to review the review the agenda real quickly or just roll right in since
Yes,
it's on the screen?
please review the agenda, Lisa.
Yes, thanks, Lisa.
Sure. Yeah, so we've made it through the first item. We're going to begin with a brief update on the GSP development, financial budget and schedule update. And then the bulk of the meeting is going to be devoted to discussing the preliminary groundwater model results. We're going to have some presentations on the expert panel review that was conducted of the model, and then the historical water budget and current water budget results. We're going to have a lot of time for questions and answers and comments, so we look forward to your questions and input on that. And then the last part of the meeting was designed to be kind of a more technical discussion for those who are interested. We'll be presenting the model validation, some groundwater model input parameters, and again, provide more opportunity for questions and comments on the model. So with that, we can turn it over to Tony Emmert, and I will stop sharing the screen and to talk about the financial budget update.
Also, while we're switching screens, just to let you know, our City of Fillmore representative is Tim Hilgren. He is not able to attend today. And then also Gordon Kimball will be joining soon, and he's on the Pumpers Associations as well. So we'll have our full.
Looks like Gordon is on now.
Oh, great.
I don't see Tim yet.
No, Tim will we're going to have a new representative from the city of Fillmore when they appoint in January. Thank you. Go ahead.
Okay, do you see my presentation screen?
Yes.
Yes.
Okay, we're gonna run quickly through the budget, and then Tony Morgan will talk a little bit more about the schedule. But our budget is very simple. We have a task for this agency to start off is to comply with the Sustainable Groundwater Management Act. So really everything we're doing and all of the things that are in our work plan and our budget are geared towards getting us into compliance with that act. We also, another budget goal will be to maximize a $1.5 million grant that the state of California Department of Water Resources granted this agency. And that includes the development of all the documents and the planning for SGMA, as well as construction of some monitoring wells. And we are also have geared our work efforts towards maximizing in-kind technical services benefits that United Water Conservation District provides. So we're intending to make full use of the recently expanded regional groundwater model and its capabilities to do some forward modeling to help us to better plan and to anticipate likely outcomes of our actions. And then, you know, we are looking to, we're not looking to build any kingdoms with this agency, but we're looking to be modest, to comply with the rules and to get the job done and keep our costs as low as possible. We have an ambitious schedule, and I won't go into that, but the key deadline is that by about this time next year, we have to have 2 sustainability plans completed and ready to submit to the state by January 2022. There's a lot of work to go on between now and then, and our budgets are set to do that. Our primary activities in this fiscal year, so we're about halfway through this budget year. We started July 1st. And so some key things that we were attempting to finish was expansion of the groundwater model that I mentioned a few minutes ago. So calibration is completed, validation is completed, and staff is busily working on completing the documentation either by the end of this month or very first few days of January. There's also been peer review that you'll hear about. So all of that is, I think I can speak for staff that's been working hard on this effort, and they wish that they were done 6 months ago, but I think it's safe to say that it is in time for us to still be able to use it for our planning efforts for this agency. There have been many technical memos written and more to come out. We're in the midst of developing sustainable management criteria. So those are our local objectives that we're trying to set, and more to come on that as we move forward. And then public review is a critical part of the Sustainable Groundwater Management Act. And I feel pretty proud of this agency that the board and consultants and staff have been very open and have been extremely flexible in doing our best, even in this COVID-19 year, to try to make sure that we have as good a public outreach and engagement as we can. Implementing the outreach plan, we have had several workshops and we have more to come. We do try to set up presentations at our board meetings to be interesting and engaging for folks that would listen in. We used to be able to have people join us in the city of Fillmore City Hall, and now we just join on Zoom, so it's less traveling. We do have a social media presence. We have our board meetings on our website, and we have a growing list of email addresses. So If people want to be added to the email list and receive updates on things, please please let our clerk of the board, Eva, know, and she can add you to the list and make sure you get the latest and greatest from the Fillmore and Piru Basins GSA. Our other activities that I mentioned, we are moving forward on some monitoring wells. It's a very good thing to have 75% of the construction of monitoring wells funded by the state, and we only have to fund 25% of it. So we are working through that process, and we're hoping to get all the way up to the point where we have the monitoring wells sited, the easement agreements done, any kind of CEQA that we need to do, and have our preliminary designs completed and be ready to go out to secure a driller by the end of this fiscal year. So somewhere around May or June, we'd like to be able to do that. And then we would get into construction of those wells in the July, August, September period, and in time to be able to submit our invoices to DWR before the end of the grant period. And our groundwater charges are $12 an acre foot, and we anticipate that's going to be a likely level of funding for this next year and maybe the year after that, and depending on whether our plan includes projects and programs or not. If it turns out that the plan does not require us to spend much money on things, then it's possible that those fees could go down, because the heavy lifting right now, as far as the budget is concerned, is getting these plans completed and submitted by the due date of January 2022, and also finishing the monitoring wells. So so after that, there may be a time that we don't have to be spending too much money. So that's our goal on that. And that's my 5.5 minute overview of our budget and our rates. And are there any questions? Lisa, do you see any questions in the chat box?
Yes. Yes, we have one question in the chat box. The question is, will Zoom still take place even when we get back to normal?
This is Kelly Long. That's a great question. We'll be looking into that, since it seems that we get more stakeholder showing up when we do have Zoom, but we'll discuss that as a board. I know that from the county's perspective and what is going on with COVID, it's not going to be till next year spring at least. So just you know, and as soon as we do change our meeting arrangement, we'll let people know. Is that good, or is there anything else, Tony, that we should add to that?
I think that's good. United has been trying to do hybrid meetings where we have some board members in the room and some that are on Zoom, and it's more challenging, I think, because of microphones and speakers in the room. We've seemed to have gotten that dialed in pretty well, but I would imagine that would be difficult to do at the Fillmore City Hall, because we don't really have access as just a visitor. We don't really have access to any of the equipment in the room. So we usually have to haul our equipment in there. So that's something that we can consider, but you know, we are going to be meeting frequently, likely for the next year, and this doesn't seem to be a bad format. So I mean, it's certainly the board's pleasure, but you know, there's no reason we couldn't continue with this format until our plans are done.
Yeah, we'll definitely be looking at it every month, depending on where our meetings are held and what the technology capabilities are there as well. Thank you for that question. All right, are there any others? Any raised hands?
I'm not seeing any raised hands or questions in the chat box.
All right, let's move to the next item then.
I'm not sure, Tony Morgan, were you going to add anything on the project schedule?
No, not at this time.
Okay, great. Then I think we've got Dan Dittmer up next with the groundwater model results to kick that off.
Okay, thank you. I'm just going to introduce this item, and Dr. Jason Sun's here to detail in specifics how our progress to date, but I just wanted to frame up the discussion a little bit and remind people how we got here. United's board authorized United staff to develop a regional groundwater flow model for the district's use. And we started that work in 2012 when we hired Dr. Jason Sun. And for the first 6 years, we worked on the Oxnard Coastal Plain. So we developed a model for the West Las Posas, Pleasant Valley, and Oxnard basins. That was pressed into use almost immediately when it was completed for the Fox Canyon GMA's GSP development, and that took place in 2018 and early 2019. Since that time, we've expanded the model domain up the Santa Clara River Valley, as you well know, into the Santa Paula, Fillmore, and Piru basins. So these basins are a little bit different. They're unconfined basins. Most of the basins on the coast are confined settings, and we struggled for a while on our recharge elements, the relatively flashy natural stream flow that comes and goes from those storms, and compared to our well-documented recharge from the reservoir releases, which is several months long. And we tried to average those recharge, those flows over a monthly period, as we did on the plain quite effectively, and we didn't achieve satisfactory results. So we went to a daily time step on surface water inputs. So that allowed us to preserve the daily flows from the reservoir releases, the very continuous recharge elements, but also capture the more variable recharge elements from the natural recharge. So we're a little behind where we wanted to be as far as model development, but now we're in a good place, and we're working hard to actually press this model into service. So I just wanted a couple other comments about the model. This is a regional model, so we have 2,000 foot cells, 2,000 by 2,000 foot in plan view, and then the layering, we also had to map all the hydrostratigraphic units, or all the aquifer and aquitard units. And so we have various thicknesses. We have these building blocks of the model where we mapped out the geology. And so that's an approximation of the real underground situation, and our daily stream flows are an approximation of what actually happens every day. So even though the mathematics and the computations of the model are very precise, they're very much an approximation or a model of a very complex system. So the process is really, we're well set up to do this because we have extensive water level monitoring and measurements. We have stream flow measurements, and we have pumping records. Many basins do not have the pumping records where every 6 months the well production is reported to United, and we scale those to a monthly scale to approximate what happened. So the data collection, the data collection that United and the County of Ventura and others perform in this area really enables us to build a good model, a well-calibrated model, and that's what Jason's about to discuss. So there's two parts to this modeling. There's the historical model where we calibrate. We have our known recharge elements and our known extractions and our known water levels, and then we calibrate the best we can and try and match those observations. And then we go into a forward modeling exercise where we don't know what's going to happen in the future. So we take a past historical period of 75 years in this case, and that's going to give us a range of values or a range of anticipated conditions for the GSA to contemplate. So it's not a predictive future. We don't know what the rain is going to be next month, much less 50 years from now. but it's fair to assume with a climate change scaling factors that will capture the range of future conditions. And that's what we're trying to, that's our planning exercise. So I hope that's helpful just to kind of characterize where we've been and where we're going. And we think this is a really good tool, but there's certainly limitations. There's some site-specific issues that aren't going to be answered by this tool, local pumping impacts, or some of the surface water impacts. And those complexities are just very difficult to capture in a regional groundwater flow model. So with that, I'll turn it over to Jason. He's going to talk about, in more specifics, about what we've done and characterize our progress.
Okay, thanks, Dan. And so good evening, everyone. Chair Long, member of the board of the public, good evening. So my name is Jason Sun, United Water staff. And today I'm going to present on my work on the model. Let me turn into the slide mode. Let me see. Okay, so I think this one is working. I hope you can hear me clearly. And if there's any question, if you cannot hear me clearly, try to speak up or make it known to Dan and someone that will pass on the information to me. Okay. So today I'm going to talk the first. There are two presentation I'm going to give. First, on the groundwater model and the water budget. Okay. Okay, so I think I want to turn off my camera so that I could save some bandwidth. Let me see if I can do it real quick. Okay, yeah, I think you can hear me. So I don't want to use up too much bandwidth so that I could maintain a good quality. So today on the first presentation, I'm going to touch on the expert panel review, historical water budget, and the groundwater model water budget as listed in the flyer. So the first expert panel. As Dan mentioned earlier, United Water started to build a model in about 2013. And as we moved, the first few years, it was a little bit difficult. And in 2016, we started making good progress. And at that time, we decided to hire some external expert to review the model. As you may know, you can imagine that the United Water hire a new modeler to develop the model. Who knows how good it is? He is. So we want to make sure the model is good because we want to use this model for long term, and we want to use model for many policy making and other management. And also, we don't want to build a model, calibrate it at the end, and have it review. And if there's any problem, then we have to backtrack and redo it. So at that time, it was a good decision is to, okay, as the model is getting better, we want to have it review early so that if there's any problem, we want to have it addressed while we continue to calibrate. And we have several rounds of review in 16, 17, and 18. And in 2018, as everyone knows, we released the model. That covered the coastal plain. And then after that, we continue to expand the model in the past 2 years and to cover the river basin. So now we have the complete model that covering from the coastal up all the way, coastal area up to Fillmore, Piru, okay? And we finished recently, a couple of months ago, and also had the review. And I'd like to go a little bit detail on our review process. Before I go there, I'd like to introduce our model on the paper that we didn't, pick up modeler from, some bus stop in downtown LA and have it to review our model. We actually tried to find the best model we could get for our expert panel. So we talk to people and we we was fortunate to have these three distinguished modelers to review our work. First is Dr. Penday. He is a well-known modeler in the United States. His work is so good that he was nominated as the member of the National Academy of Engineering. It's very rare for modeler to have that kind of recognition. And he's the author of the MAFlow, and also he also is part, I believe he's part of the USGS modeling development team, because I have problem, when I have problem talking to him, he would always, you know, if some problem, he would talk to the actual USGS developer and then try to answer any question I may have. And second one is Jim Rumbaugh. He is the author of the popular MAFlow. MAFlow is the groundwater model. It's a tool, software, groundwater vistas. And because the groundwater vistas was pretty popular, I think it's the most popular software in the United States. So a lot of modelers actually reach out to Jim Rumbaugh for any question. And Jim Rumbaugh was, you know, in a good position and has this exposure to various kind of groundwater model in the United States. And also we have the John Porcello, who has worked on in the Southern California area, and is very familiar with the local geology. So we have this interesting team that in terms of technical, you know, MAFlow, this model, we have Dr. Penday. In terms of general practice, you know, why experience, we have Jim Rumbaugh, who has seen a lot of model. And then we couple with a person who is really know the local geology. So we kind of have this nice, I call it dream team to review our model, okay? And the way we work is that we don't just like, you know, give a simple review and a paper review. We actually go very detailed. We invite the panel to our office, and then we gave presentation. We provide all the information to get them up to speed. And then we give them the information, conceptual model, all the data, water level data, pumping record, the model input file and output file that we build. We send those things along to the expert panel. And the panel spend days and days and weeks each round to pour through the data. We wanted to look at the conceptual model. We want to look at the data. We particularly want to look at the model, each file, each component, each package. Are they built properly? And then look at the output. We produce our own pre-processing. We prepare the input file. We produce the output file. We do the post-processing, right? We produce all the results. We didn't just ask him to look at our result. They actually independently reproduce their post-processing and look at their result and go that kind of detail to review our work. And also when we have documentation, we also send along for their review and review our documentation. And we expect the expert panel will continue to review our work in the future. Okay. So the goal is, as I mentioned earlier, is really we want the panel to really dig into our model, from model construction, the boundary condition, the pumping, recharge, grid spacing, time step, numerical convergency. We want him to look at really in great detail to make sure it is good. And then they independently check the model calibration, because we send them the water level data and they do their study and look at any model discrepancy residual. Okay, and the goal is really coming down this, that as a public agency, we do like our tool to be a really defensible tool. It's a defensible model. that is consistent with the industry practice. We use the Marflow package appropriately. It's consistent with the conceptual model. And of course, we want a good calibration that they look at it and agree, okay? And as I mentioned that we have produced 2018 model. So they reviewed the model and concluded that our 2018 model is well-designed, well-calibrated tool. And they are happy with the calibration, the quality. That was the 2018 model. In the past 2 years, we built the expanded model so to cover the river basins. So I call it 2020 model. And we finished earlier this year. We have three review by the expert panel. And this is their conclusion on our newly expanded model, that they think our model calibration to both heads and stream flow is very good. Now, remember that the 2018 model, it didn't really have a long stream like Santa Clara River to simulate. But with the river basins, we have this important Santa Clara River to simulate. It's one of the most important component in the model. And our expert panel look at the groundwater level data, look at the groundwater component and the surface water component of the model, and they conclude that the calibration is very good. Okay, and here I'd like to emphasize a little bit. When you look at a model, it could be a different level of conclusion on the calibration. You could say the calibration is good, or you could say very good. And to me, very good, it really speak a lot, meaning our work is actually pretty good, okay? And I also like to mention that in addition to the review by the expert panel, our model, United Water model, actually was reviewed not just by our expert panel. Of course, we have an internal review by our staff, hydrologists and hydrogeologists. Our model is also was reviewed by a Stanford professor. 2018 model was also scrutinized in the litigation. And so far, I have not heard anything back from either the litigation, their expert looking at our model, from Stanford professors, from others that who come back and has question or has any comments on the quality of our model. So I consider the quality of our United Water model is very good and is better tested. Okay. Okay, that kind of sum up the panel review. The next thing I want to touch on is the historical water budget. First, I want to make it clear is that I didn't do this historical water budget. It was done by our staff, Dr. Zach Hansen. And the way we operate within United Water is Dr. Hansen did this historical water budget independently, okay? So we didn't work together to look at the data. He basically looked at it independently from me while I work on the groundwater model. So that means that I didn't really use the historical model as the given fact and they build a model. We kind of do it separately so that at the end we can compare the result. So this is a little bit different because some models like to have historical flow water budget as the blueprint to build model, but that's not how we do it here because we kind of want to do it, especially for me, I like to do it in this way so that the model will be a better, more objective. And the bottom line is we look at the calibration. If it's good, it's good. It really doesn't matter how you want to start it, okay? And then let me go to next slide. And make sure I know how to do it. Okay, so this is just give you the help you if you are interested in the historical water budget. you could easily to download our report that we have published on our historical water budget that we show here, and you can go to our website to download it. Okay, so I just this slide is in case you are interested. Then after the presentation, if you have the slide, and you can go and find the information you want. Okay, now next. Oops, for some reason. Okay, so this is really the next one is really the meat of the budget. Okay, and here it show you where the source that we review, that's Dr. Hansen review. Okay, and here is what the data he reviewed, Zach collected. And here, Piru Basin, vertical here. Okay, there's a lower range, upper range. Fillmore is here on the right. And they separate by inflow. I hope you can see my mouse because I'm pointing it. So this is inflow. Oops, go back, sorry. Now I know. Okay, so you have an inflow and then there's outflow. Okay, and each component has a range because different data source may come up with different value, and Dr. Hansen did a good job of compiling together and give us the range that based on the literature review. And you can see, for example, in Piru Basin, subsurface underflow, the range is 240 acre feet annually to more than 18,000. In the upper end. And this is the underflow from LA County, okay? And the stream flow information percolation estimate, precip recharge estimate, and so on. And then you look at the outflow here, further down, the subsurface outflow. This is outflow, this is surface underflow going to Fillmore. So you can see the ranges from 12,000 to more than 111,000. Okay, and this number will be the same as if you look at a Fillmore Basin here, the inflow surface underflow is the same because this is from Piru flowing to Fillmore. Okay, so you have the same value. And then you have other things, they just compare it. And I think here is just give you a range, but I really thought is important is to compare this as close as possible with the groundwater model. And I think I like to use the time there instead of going to there. Instead, I think I want to pair it with the groundwater model output flow budget and have a better comparison. So I'm going to move to the next page. And here's another slide that just give you the list of the references we check. That if you are in, you can download the probably it's the PDF of my presentation, and you look at this slide, then you can go find where the sources that Zach reviewed. Okay. Now here I'm gonna go to the groundwater model water budget. Okay, and now here Jason? Is the yes.
I thought this might be a good breaking point. Just we had a general question. It was answered in the chat, but just in case others are wondering, the question was: is the same model? Yeah, if this is a good breaking point for you, is the same model used for both Piru and Fillmore basins, or are there two separate models, one for each? And Dan answered it in the chat that it's one model.
Yes.
For the whole river valley plain. But the water budgets and conditions will be characterized for individual basins. So if there's anything you wanted to add.
Yes. So there's only one model. The current model that we just finished is it cover all the basins within Ventura County. It's just one model covering from Piru, Fillmore, Santa Paula, Oxnard Basin, Mount Basin, Pleasant Valley, and West Las Posas. That all together, one model is all connected, right? Now, in terms of the flow budget, we show it by basin is because once we have this flow model and we could look at each basin and what's the flow coming in, coming out. So you may see each basin has a flow budget. It doesn't mean it's from different model. It's from one model because this model is a regional model covering several basins. And for each basin, we could calculate the inflow and outflow for each basin, and we tabulate it here. And the reason I show here by basin is because in the past, the literature review did have this information, and I think it's good to look at it basin by basin. Okay, I hope I answered that question. Is any other question that
I'm not seeing any at this time.
Okay, so I'll continue. You're gonna have a chance to ask me more questions because this is almost the end of my first presentation. So if you look at it, the Piru Basin, what you are showing here. So average, mean, minimum, maximum value is from the groundwater model water budget, okay? Have an inflow and outflow, okay? Similar thing. And then you have this historical water budget. This is the number I copied on the right, the two column, lower and upper. I copied it from, let me show you back. Oops. I copy it from here, okay? I just thought it's easier to compare. So let's look at the Piru Basin, the subsurface inflow. This is from LA County, okay? The historical is giving us a pretty wide range. And I end up with 5,000 acre feet a year. And there's a reason for that, because I think we are fortunate to have the modeler building the LA County side that actually is our expert panel too, John Porcello. So early, I think it's beginning of this year that I talked to him about, we look at the literature review and it's quite wide range. And I try several number, I try high value up to 10,000. And John Porcello, he shared with me their model actually is predicting, their calibrated model is showing that the flux entering Piru Basin is about 7,500 acre feet. But their model doesn't consider the stone flow component included in their model. But our model include the stone flow. We basically have all the flow in surface flow in the model. So I look at it and I try different value and calibrate it. And it seems to me 5,000 is reasonable. And I think it's good because if the LA County side, they are predicting non-stone flow influx at 7,500. And our model, we just look at the underflow is 5,000 plus stone flow. And I thought this value is reasonable. And then you can look at the second one is the stream percolation. We calculate this, average is 40,000. If you look at their range, their stream percolation is quite wide range. It's within the range, okay? And then in their side, there's also a rising groundwater here, but I didn't calculate that one, okay? And the recharge here, I want to emphasize the recharge from the groundwater model include precipitation, apply water on the surface like irrigation, return flow, precipitation, return flow, spreading ground, Piru Basin, spreading ground, return flow, all added together, okay? And on the right-hand side, the historical water budget, they actually have this precipitation recharge. The range is quite wide, and there's managed recharge. I believe this mainly probably is the Piru, United Waters, Piru spreading ground. Okay, but this is much earlier data. Nowadays, Piru Basin, we don't operate there. Okay, and mountain farm free recharge, I have a wider range because we have pretty drastic precipitation, but their historical budget is kind of constant. Okay, and then let's see the outflow. Okay, this outflow to Piru Basin, and the surface subsurface underflow. This outflow is going to not not Piru, from Piru to Fillmore Basin, and you can see the average is 46,000. Okay, and historical their value is a little bit wider range. Okay, our model is within their range. Pumping probably is that's you know that's controversial because we basically have this number based on the pumping record. And here his historical water budget is a bit complex. It's consumptive use, meaning they consider the water pumped out and put to use, and then subtract the return flow back to the aquifer, and also subtract ET. So it's a little bit complex. And if you have a question on this, Zach is also here. You can ask the question, and he's the better person than me to answer the question. And also we have ET component, average about 5,000 in Piru Basin. Okay. And let's look at the Fillmore Basin. Subsurface flow, this is from Piru. I mentioned that already. Stream percolation, this is interesting because you are seeing is actually Fillmore has a more rising groundwater, because in some year, because when the water is pretty wet, the groundwater level cannot come up, you actually see losing water to the stream flow. Okay, and the average is here. Okay, recharge is within the range. Modern from is higher than the historical value. And then here is the subsurface underflow to Santa Paula. Now we are outflow from Fillmore is going to Santa Paula, right? So the average is about 19,000 acre feet. It's within their range, okay? And pumping, this is really based on pumping record. And we have ET. And one thing I thought is important to point out is, if you look at the rising groundwater here, Fillmore is a little bit stronger, has a more significant rising groundwater. If you, let me back up the slide one more. Now remember this value, the higher value is 48,000. Now we back up. Okay, it's at 37, right? So you can see, and similarly, if you look at our stream percolation, this is 40, right? Now it's much less. So that meaning it's kind of, the pattern is there, that Piru have more percolation from the surface than Fillmore. Okay, so overall, when we look at this groundwater water budget compared with the historical water budget, it's important to recognize that we are comparing apple with orange. Okay, it's, you cannot say one is better than the other, but what you could say is groundwater model incorporate more information, because incorporate the spatial data, pumping in great detail, three-dimensional data. Historical water budget is more or less, is more not as extensive, as detailed, or not as sophisticated as groundwater model. Okay, but overall the comparison I thought is not bad, and that kind of conclude my first talk. And I list this table here just in case any question, then I don't have to flip back and forth. Okay, so I'm gonna, so if you have any question, I'll be happy to ask. Or if you have question on the historical water budget, Zach Hansen is also available. Thank you.
Thanks, Jason.
right.
If anybody has any questions, go ahead.
No, go ahead. Same thing. Does anyone have
Oh.
any questions? Anyone in the chat, or? I know that is very detailed.
It's a lot to absorb.
Mm-hmm.
Maybe Zach, you could just add a little more context to that. Like those historical periods were different climatic periods. There's different methodology. Probably our current model is better calibrated than some of those past estimates. And so we don't necessarily expect to have the same range of values as the historical studies. And, you know, what I don't want people to do is take an average, presume a median point of the historic averages and compare that to our average value for our calibration period. And so if you want
No,
to.
the historical doesn't have average. It's just lower and upper values.
Right, but I just want to caution people that don't try and take the median value and think our average should be
Yeah.
that value.
No, that's not how the
Right.
average is. It's not the average of minimal and maximum. It's not that way.
Exactly.
Right, as Jason pointed out, that the United report that he was referring to, those were from the 1930s all the way to 2017. So everybody was looking at different periods for different reports, and that's where we were kind of reviewing those and grabbing out these max and mins, and they're all representing different climatic periods. And so that's where we didn't feel like we wanted to try to average some condition because the periods were all varying. But I guess one note to make on top of that presentation from Jason was mainly that Piru basin boundary. One of the large reasons why we have that large range, especially there, is because the boundary has changed over time too, from the 1950s where it's below blue cut area, or and then more currently it's near that the actual county line. And so the geology is very different in those locations. One's much thinner, and so you're going to expect a lot less subsurface underflow as opposed to near to the county line where it's much thicker aquifer material for the subsurface underflow to transmit the water through. So that helped add to that range.
Thanks.
And can we also state that this presentation, the PDF, will be on our Fillmore Piru Groundwater Sustainable Agency's website as a resource, so that I know this information is being talked about, and sometimes we need time to absorb all the information. So I want to make sure people know that it's going to be there too. Thank you. All right, if there are no other questions, let's go to the, oh, there's one right now from Letta Spencer. Will the basin yield be covered later in the presentation?
Would you say again?
Will the basin yield be covered later in the
Okay.
presentation?
Nope. Yeah. No, we didn't really back up a little bit. We have the flow budget. Okay, we have the flow budget for each basin, and this basin yield, it's a question of how we calculated how much coming in, coming out, that we could interpret some kind of basin yield out of it. But I didn't prepare today. But that's something that I believe it will be in the GSP. And this is one important component that definitely it will be touched on, but not today.
Okay, thank you. And then there's another one. What units do the numbers represent in the table?
Oh, acre feet.
Acre feet.
And it's annual.
Dang it.
Okay, so we need to make sure our measures of units of measures are on there to make sure there's no assumptions.
Yeah, I think it's showing here acre feet annually. Okay.
Okay. Yeah, it just, if we could put it on each slide, then that helps everybody.
And I almost forgot. And also, I sent out a PDF to Eva. If he sent it out and you have the copy, please be aware that there's a typo here. That this I typed 255,000, so actually it's 25,000.
Oh, I really like the number 255,000.
Yeah, I love it too, but I have to be honest about that.
Thank you. We want to set the right expectations, that's for sure.
Okay, just a typo.
Okay.
Yeah.
Well, with that, do we have any more questions? I think that's it. So then, Lisa, if we can go to the next one.
I think we roll right over into the technical session again with Dr. Jason Sun as our presenter.
Okay, so I'm gonna start the second session, and this is on the groundwater model technical session. So we try to go a little more detail on two specific topics. One is model validation, and the second is the input parameters. And I think I'm going to spend more time on the validation. As Dan mentioned, that we have done 2 phases in the model development. First is calibration, and I believe in my last presentation I mentioned that I did show you some of the result, and that result is only calibrated up to 2015. I'm using the data from 1985 up to 2015. And we have calibrated, have the review. Everyone's happy. But we want to test the model again using a new set of data to see, okay, the so-called calibrated model, how good it holds with a new set of data. And that's validation. And we are using a new set of data from 2016 to 2019 to test our model. In a way, this is like I'm defending my thesis. Okay, so we use 2016, 2019 data set. And we collect a lot of data from precipitation, pumping, stream flow, diversion, and so on, wastewater treatment. And this data collection is not a simple task, and it's made possible by Zach. And also I'd like to acknowledge the local agencies from GMA, cities, Fillmore, Piru, and also local agencies, the farmers irrigation company, private diverter, the operator, the private diversion, for their sharing the information that make our data collection better and possible. Okay. So as I mentioned, so our groundwater model, we extend the model from 2015 and extend all the way up to 2019. And our conclusion is, giving you the conclusion first, is that the model calibration remain well calibrated. The model is well calibrated with the 2016, 2019 data. When we look at the water level data. And also we look at the surface water level, surface stream flow data. And our hydrologists review the surface water result and conclude that the 2016, 2019 surface water simulation, the validation is also good. So we look at it and we feel confident and conclude that the validation is good. And let me go to the detail of the validation result. First, this is a scatter plot. For those who are not familiar with it, it's basically, what I did is, here is the water level measurement. The vertical size is simulated water level, right? So for every water level measurement, there is a corresponding simulated water level. In a perfect model, in a perfect world, they are equal and they will fall along this dashed line. But the reality is the model is never perfect. The data is not perfect. So there are some residual error and discrepancy. But we do hope a well-calibrated model, the data point will fall along this 45-degree line. The closer they compact together, that means the better the calibration. And this is our calibration from 85 to 15. And it is very well calibrated because it's really clustered tightly along this 45-degree line. Now remember, this is a regional model. Okay, so the model itself is, to me, I look at it, this calibration means very good. Then let's add the new data and see how it goes. Okay. So I add the 2016 to 2019 data, and that's in blue. And you can look at it. It's still nicely clustered along the 45-degree line, right? So that means when I put all the water level data, I just want to have a first impression, how good this calibration is. This figure telling me is with all the data putting in there, the calibration is good, okay? And now this is just putting all the water level there across 7 basins, right? And let's look at each basin and to see any local basin if the calibration, the validation is still good. Here is just looking at the 4-bay Oxnard Plain, PV, and MAU. The top one here is 85 to 15, this is calibration, okay? And then if you look at the lower one, it's the new data set. That's from 16 to 19 validation period. And if you look at it, their patterns are similar. So there's no, what's the word? There's no new unexpected error you are seeing. And so what you see is, okay, 4-bay, they behave similarly. Oxnard Plain, similarly. PV and MAU, they are similarly, okay? So that means there is no unexpected result. And then if we look at the hydrograph, and I'm gonna just use this one, and I wanna spend more time on the Fillmore Piru, and you can see this well, Oxnard Plain, for example, on the left is calibration period, okay? And you can see for this particular well, okay, the calibration show here. And if you look at this ended at here, that's 2015. And on the right, showing you here is from 16 to 19. It's give you, I kind of, expand the axis so that you can see it clearly. You can see that the trend is good. And of course, in the calibration period, the model show a little bit overestimate, and in the validation is similar, okay? No surprise there. And then you look at the lower one here. This well actually calibrate much better. It captured the data really nicely. And how about the validation period on the right? It also captured the data nicely. So that means it's telling me the validation is very good, okay? And then let's look at that, what's really is river basin that you might be more interested. This is Piru Basin on the left, Fillmore, and Santa Paula, okay? The top one is the calibration period. And you compare the Piru here, the left, okay? And you look at the down one is the validation period. They are about the same. The way it's scattered, the data scatter is about the same. Same thing applied to Fillmore. We are not seeing some data point that's kind of not expected. And Santa Paula, they are all behaving similarly. So this is consistent verification that the model is behaving as expected, as in the calibration period. And let's examine each well. So we have done we put all the data together from the first scatter plot, look at each basin, the scatter plot, then look at each well. And here we look at 2 wells for Piru. The top one here is an interesting one. If you look at here at the end of 2015 here, there's a little bit gap in the water level data. The reason is this well 20 M2, it went dry because water level go below the screen interval, okay? And if you look at the validation period, it support that because the simulated water level actually go further down before it's bounced back. And the model captured the rebound nicely. And now you look at the second well in Piru, 20R1, okay? It captured nicely, but this is a deep well. So you have water level data in 2016, 17, because it's a deep well, it didn't went dry. How good is the validation? It still captured nicely too, okay? So it tells me, again, one more confirmation, the model is doing well in the validation period, okay? Let's look at Fillmore Basin, 2 wells. On the left, validation. On the right, No, sorry, on the left, calibration, on the right, validation. Okay, look at the top one, 1P2. The calibration is pretty good. How about the validation? Starting from 16 to 19. To me, it looks pretty good. And the low one, 1C4. Okay, capture, not bad. Okay, and you look at the validation. It didn't go all the way down, but it captured the rebound. Okay, it's important for you, for we as model and also to the public to know that we are not expecting the model to capture every up, the high point, the low point. The model is not possible to calibrate the simulated water level to every well perfectly. There's always some limitation because of the input parameters, because of the limitation, because of the grid spacing. It's not going to be perfect at each well, at every water level measurement. But it's important that to see is put all the data together for each well. Are we capturing the trend? Is the residual small enough? And to me, I look at all this validation, it's pretty good, okay? I think there's another one, that's a Santa Paula, this 11H3. You can look at on the left is the calibration from 85 to 2015. I hope you kind of familiar with so this orange line are the simulated water value. I forgot to tell you in the beginning, sorry about that. And the blue dots are the measurement. So it's kind of capturing the fluctuation. Let's look at the 16 to 19. It also captured it nicely. And because you want to pay attention because I kind of zoom in, make it bigger so that you see a little more detail. But if you look at the lab, you look a little bit because of scale difference, but both are pretty good, okay? Now, so I just show you is the groundwater component. We look at the groundwater level measurement and see how the simulated water level compare with the measurement. And to me, from the scatter plot, from each basin, on the scatter plot for each basin, and also inspecting the individual wells, the validation to me is pretty good. That's one component. In river basins, there's another important component, that's surface water. Now, for the surface water, there is some limitation because we have some stream gauges at the county line, at the Santa Felicia Dam, and also a number of the upstream area, and also a Freeman diversion. Okay, we don't really have good stream measurement between Fillmore, Piru within the valley floor, but we do have some measurement that United Water staff collected that during the releases, that we did 2 releases, 17 and 19, that we do 2 releases. When we do releases, we collect measurement, how much water percolate within the basins. And also we collect the stream flow at the basin boundary. And here's the data that our staff collected and we could compare. So you look at how much recharge in Piru, Fillmore, and Santa Paula. And you can see the blue line are observed, and then the model value is in orange. You can see 2017 and 19. And overall, it looks, the model capture the percolation reasonably good. And then you look at the right, the stream flow at Freeman diversion, that simulated stream flow reaching Freeman diversion is also good, okay? The second thing we also look at is the stream flow boundary, okay, at the basin boundary. And here, this is the boundary. On the top left is the boundary between Piru and Fillmore. On the left are the calibration period. And this is our result. The calibration is good. Okay, our hydrology look at the correlation is good. And let's look at the stream flow at 2016 and 19. And our hydrology look at it, the releases and the stream flow at the basin boundary is pretty good too. Okay. And then we look at one more thing, that's stream gaining and losing. And we, in the calibration period, we already noticed that to simulate the gaining and losing within the stream channel is not easy, because you can imagine a couple feet water level difference in groundwater could easily change the stream from gaining to losing, or vice versa. So a couple feet difference is such high precision that usually groundwater model is not that precise. So it's not expected for the groundwater model to simulate perfectly on the stream gaining and losing. And it happened here too. Particularly the groundwater model is typically would underestimate the stream flow, particularly in the base flow. And the reason is the limitation of their stream package, because groundwater model is a groundwater model to simulate groundwater. Okay, the surface water component is like an add-on package, and it's not a full-blown surface water routing package. So there's a limitation. So when you use groundwater model to simulate surface water stream flow routing, you tend to see a bit underestimate, and it happened here to our model. Okay. And then we look at also the stream flow reaching Freeman diversion. And you can see that on the top, we see from 2016 to 2019, the model did reasonably well. Okay, and the scale is from 0 to 100,000. Let's go look a little more detail. Let's just say look at 0 to up to 10,000, and you can see the detail that. And for our hydrologists who review our stream flow record and doing the stream flow modeling and analysis, and their conclusion is the stream flow is also good. Okay. So with the review that we look at the groundwater level data, as I shown earlier, and also by our hydrologists looking at the stream flow data, that we conclude that the model validation is good, and we don't plan to change the model. Okay, so our model with this completed the validation period, so our model is basically extended to 2019. So the whole model now is from 85 to 2019. And we recognize some model limitation, but we think the groundwater model is adequate for regional scale analysis, particularly GSP studies. Okay. And the next topic, so I finished the validation. So next topic is the input.
Can I ask you a question? There's a couple of comments before you go to the next topic. I was wondering if we should answer those questions.
Okay.
So, okay, where was it? Rachel's was, oh, sorry. So Dan was just saying that all water levels in feet and above sea level, and that the Freeman diversion is in Santa Paula Basin, downstream of Fillmore, but where we are daily stream flows. The only question, does anyone have any questions on what we are talking about right now? Any directors? Anyone? The question I just had was in regards to when we purchase water. How do we, with model validation and so forth? Is that abnormal, or when we're doing modeling, how do we account for when we purchase water versus what we normally get?
Oh, okay. So suppose, no, actually the model similarity include the imported water that,
Right.
Article 21 water that we secure a couple of years ago, and the model simulated. So for your question, say if you want to understand that, hey, I want to bring in this amount of water, what's the impact at this particular month or this particular year? You want to bring in this much water, what's the impact? The model, the good thing about having a model is, okay, we run the model, adding this extra water at the point of you want to discharge at that location. If it's physically possible, we'll simulate that. We'll run the model, is surface water flow, and we'll add that to the model, and some water would perk down and some may flow out, and the model would simulate that.
Okay, and then will it do the same for when you extract those numbers?
Yes.
Because that's really an artificial
yes.
inflation, isn't it?
Yeah. So the good thing about model is it pretty much you can do anything that the model already has. Suppose you want to increase pumping, you want to reduce pumping, you want to assume it's going to rain every month for 10 years, or you're going to assume it's dry for 10 years, the model could simulate that.
I would love to simulate all that rain. No. I just wanted to ask and make sure, because there are those in past meetings who have asked about purchasing water and how that would do. And so it's good for us to understand the limitations or what we can and can't do with this. So I appreciate that. Thank you. Are there any other questions?
So Jason, I had a question. For the analysis on the model calibration and validation being good or very good, that's all going to be summarized in a technical memo, correct?
Yes.
Okay.
Go ahead.
And then did the expert panel develop that criteria, or was that developed internally at United? Or how did we develop the criteria to make these benchmarks of very good? Because I think like there are some areas where there are, on the graphs where there's a difference of 15 feet, and it would be good in the technical memo to understand, what those buffers are on keeping it in a good validation range, and where there might be some room for concern, just as we're moving forward to inform decision making.
Okay, just to clarify that, there is a criteria when we talk about model calibration, and as the acceptable a model consider, the calibration is considered acceptable when the residual is less than 10% of the range of the water level. So that's kind of industry standard.
Okay, perfect.
Okay?
Yeah.
So that's acceptable. And our calibration is much less than that. That's why the expert panel said it's very good. From good to very good, it's not really a quantitative. It's more, you look at our model and say, oh, our residual is only 3% or 4%. It's much better than the typical model out there. So they say it's very good. So it's not like there's a number below 5% is good or not. But I would suggest a good way is to, we have, not with the Sigma, there are model that you could take a quick look easily because all the model documentation has to be available online. So you can look around, you have model, you go to GMA website, there are kayaks model. In the future, you have sea model in Southern California. Just look at the hydrograph, look at the scatter plot. I bet that you will find our model, United Waters model, is on the better side. If not the best, it's not as good or it's better. I'm pretty feel confident about that. Okay.
All right, thank you, Jason.
Jason, another question that was there is that what if we run into a 10-year or 12-year drought? Can the model perform for a drought beyond limits of history?
Yes, the model would, the way we build is we have considered that basically if you have 10-year drought, the model keep running and God forbid, you may see the aquifer went dry and the model will tell you, hey, the first layer, second, third is going dry. You know, you have this much water in the fourth, maybe in the lower aquifer. The model will simulate until the very bottom of layer 10 went dry. Then everything is dry, so we stop there.
Okay, we don't dig more. No, I'm joking.
And we could continue to expand the model if that happened. We hope not.
Okay, directors, any questions? I thought I saw Gordon. No? Okay. All right, now, any other?
Dan want to make a comment?
Yeah, I just want to comment. Our intended future climate for the time being is 1943 through 2019. So we're going to simulate a 77-year repetition of past observed climate. If we wanted to simulate a different forward climate, we could certainly do that. So if we want to do a 10 or 20-year drought, we could make that prediction and see what happened to the basins. So that's certainly possible if the board chooses to do a theoretical future climate. We can do that. And
Dan, didn't you move the date on that though? Wasn't it supposed to be 2015 for DWR for Sigma, the numbers, or am I could be incorrect? There was a date based on a certain date. It was 2015 or 2016.
I mean, that's referring to you cannot get worse than the starting point of the sigma.
Okay.
Yeah.
So you can't get any worse than that. Okay, great.
Right. And I just want to respond briefly to Candace's question. If we notice areas of poor calibration or an area where there is a systematic bias and we recognize the calibration is less good than in other areas, that's something that we can call out in the documentation. And if there's particular shortcomings or areas where we're not well calibrated, we can certainly call that out. So if there's areas of bias or just poor calibration.
Yeah, and so if you want to use say simulated result in that area with the not as good calibration, you want to use it understanding the limitation of the model, and you have to interpret accordingly. So, okay.
Okay, good to know.
And now I think I have only a couple of slides left.
Yes, go right ahead. Thank you.
Okay, so I finished the validation, and let's go to the input parameters. So I try to make it easy for you to see, and I think the most important parameters here is the hydraulic conductivity, is the permeability in soil, and I like to use the color in zone to show you, easy to show you. So here you have blue, and this is the purple. This is covering the Piru, okay? And further down, red, and is that green or that color? Anyway, is Fillmore, okay? And on to the north side of the river toward the mountain area, hillside, is another color, okay? And I'm going to use this to show you, use color to show the parameter. I think it's easy to explain. Okay. And second thing I want to mention is on the left here is in the deeper layers. And so you may see here to be more exposed out than on the right. And also, so in the deep layer, some of the area, the deep aquifer disappear. Okay, so don't be alarmed. It's just what geology is telling the model. Okay, so this is the really the parameters, input parameters, and I did it by layers, 1 to 10, and this is color coded here. And I use this little picture here on the top. You can see, you can so easily could tell this orange, sorry, this blue and purple. These the first two on the right representing Piru Basin. Okay, the red and this greenish color, this is Fillmore. Okay, and this color is the like foothill is to the north. Okay, and further north, and you have this kind of dark, I don't know what's color, how they call this. Anyway, so it's kind of give you the, and this is all in feet per day. And you can look at it and recognize the pattern that from Piru, Fillmore, Santa Paula, you can see the conductivity is decreasing. If you look at layer 1, layer 2, okay, that's the trend. And if you look at from top layer downward, it's decreasing, except Equator, of course, tend to be a little bit lower, okay? And the third observation is the foothill, the hilly area is lower too, okay? And I don't know, you guys, you are familiar with the groundwater model or conductivity. One thing to me is stand out is the conductivity is pretty high in Piru. If you look at it, 1,200 feet per day, that's pretty high. And I admit that when I started to calibrate the model beginning of the year, I tried like 500 at most. And the calibration was, was struggling, wasn't perfect, and was scratching my head. And then I had the opportunity to talk to John Porcello, who is our expert panel, and he's working on the LA County side. They are working on their model. And he shared with me that their model actually showed that their calibrate model suggests the conductivity is more than 1,000. And I look at it, I thought, wow, that's to me seemed high because I have done model so many years. I think I had never used, conductivity that high. And then, well, give it a try. And it turned out to be really make the calibration better, and it makes sense. And that's how this model is come up. It's by calibration, supported by water level data in Piru, and also is being consistent with the model on the other side of the county line, LA County. Okay, so in terms of the range, I think it's all typical for the aquifer, except in Piru, I thought in the shallow layers seemed to be high, but it's supported by the calibration, and it is also, it's also kind of get this consistency from the neighboring county too. So
yeah, hey Jason, if I can just
go ahead.
Go
ahead.
That also may be a compensation for us not getting the geology quite right if there's a lack of data or our mapping or our layering wasn't accurate. This is a way to compensate for some of those other inaccuracies to make the model calibrate. So some of this is give and take, and it may not be that high, but given our geometry, it might have to be that high, and that's just part of the process.
Yes, absolutely. And the groundwater model is built, constructed based on the assumption of the conceptual model, the knowledge of our conceptual model and to build this model. And when we know better, we know more about the data or the geology, we will implement and improve it. As I said, that we didn't finish model here and be done. We will continue to improve it if we have a better understanding of the data or others. Okay, so here is really my concluding slide that we like to apply this model. We consider this model is robust. We like to apply to support the GSAs, and Mount Basin and other basins and GMA. And we are planning to apply the model to other projects. We're gonna continue to do the documentation and some other study. And the final point, which is the most important, is that the model improvement will continue whenever we have better understanding or more data. Okay, and that concludes my second talk. And if there's any question, I'll be happy to answer.
Yeah. Thank you, Jason. I just want to clarify, we need to keep moving. We may do additional calibration work, conceptual model refinements in the future, but for the time being, that's not part of our near-term process. We need to move forward on the future simulations in support of the GSP. Those additional calibration efforts will take place after we document the current form of the model. That's what we intend to write up for the benefit of the GSAs and the GSP publications. So as much as we are invested in this product and have a long-term goal of continuing to refine it and improve it, we're not going to do that before we run the simulations for the GSA. There's just not time to do that.
Oh yes, that's for sure. That's more like a long-term goal, so that to have my job security.
Great. Job security is important. No, getting this right is really important for all of us. It's a hard thing to do with modeling, that's for sure. And I appreciate that you guys have the experience with the Fox Canyon already. Lessons learned. Luckily, we've been able to reap that reward is really what I believe. Maybe I'm wrong, but I think it is. Are there any further questions for Jason or Dan or anyone? Okay.
Kelly?
Yes, Gordon.
Not so much a question. I'd just like to say thank you, Jason, because I have a feeling that was a lot of work, and no model is a perfect representation of every rock and clay layer, and but those scattergraphs that you showed us are pretty impressive, and this will give us a great tool at the GSA to help with the planning in the beginning. And as we learn more and get more data, I'm sure it'll be even better. But without this tool, we'd be a lot blinder than we are now. So thank you very much for all your efforts, everybody at United, for putting this together in such a short time and giving us a very useful tool, very helpful. So thank you.
Thank you. And I just want to add one thing is Sigma also require or ask that the model be updated every 5 years. So the tool we have here is expected to be reviewed based on new information with more data to make it better. So it's not like we do the GSP and we're going to keep it for the next 50 years. No, there will be an update to review the result, to review the input on a periodic basis, at least every 5 years, just that you know.
Great. It is good that we're going to be updating this model, and appreciate we had our boundaries changed as well from DWR, and so that's incorporated in this model as well. There's a lot of time and effort that goes into that, so really do appreciate it. And I think that I believe that there are some thank yous on the chat as well. So great job. Appreciate it. Okay, if there's no further questions, Lisa, what's next?
Just the next steps, and then we'll wrap up.
It did look like there was one question in there. I wasn't sure if anybody got that from Logan about what if we have the 10 to 12-year drought? Was that answered?
I believe I answered that earlier, and Jason had stated that we'll run it, and basically it'll go as negative as possible to zero. Am I right, Jason?
Yes, you would run all the way, you know, the whole aquifer when dry, you know, 500, 600 feet, 1,000 feet, all the layer dry. And when you get to that, don't worry, we'll expand the model downward, add more layers, we'll carry on.
Director Pace, I believe that we answered that with the simulated climate versus the repeating the 75 years. If we want to speculate of a different forward climate, we certainly have the ability to do that.
Okay.
So the NOAA did for future climate modeling, and they had 4 different scenarios, and there was a most likely scenario for Ventura County, and it will be interesting to see how the model would respond to that most likely scenario for climate in the county. How much effort would it take to run a scenario?
Oh, we're doing that. You want to expand on that, Jason or Zach?
Yes,
Yeah.
we look at so basically there are several climate factors. So we are implementing the simulation. We are looking at the 2070 climate change factor that we believe that's the most conservative one. So we kind of, okay, let's run this one to get a better sense how under the conservative scenario, how it is like. And then after that, we'll change to apply different climate factor. Once we build a model up, 75 years or whatever, and to change the climate factor is become a little bit easy. But the first one, you build it up, it take a little bit longer. But once we build it up, we can switch, precipitation record, change factor relatively easily.
I was going to say, from the non-modeler in the group, we have a very good tool that's in our toolbox now, but then it's up to us with the board and our consultant team to put together the most useful and logical future scenarios. So to work with our neighbors to make some very reasonable assumptions and some good questions, and then ask the modeling team to run those scenarios. So that's really the next heavy lift, is for us to put together those potential futures and then run those. And obviously, in the time we have, there's only a certain amount of scenarios we can run before we have to finish our first plan and submit it. So that, that is the effort we've been working on. And as Tony Morgan a couple months ago asked for our best information on future assumptions. So assumptions on growth in the urban areas. We've met with Santa Clarita Valley Water Agency on assumptions on various factors in the upstream basin. I believe Dan Detmer has mentioned before that we're working on a surface runoff model on a separate side effort to try to get a better handle on the runoff from the upstream basin, because they don't really care about the runoff from the upstream basin because it's leaving their basin. But we care a lot about that. It's very important. So that's our next heavy lift, is really putting together some very thoughtful and good scenarios that we can run in the next couple months, and then we can include those in our plan. I think one lesson that we learned from the Fox Canyon GMA that left people a little bit disappointed was that I think there maybe wasn't as much effort to try to put together creative and thoughtful scenarios as a future. And so, you know, I kind of got to the end of the model runs and people said, is that all there is? You know, didn't we simulate projects or any other things? And so I think we, you know, we want to really think hard about that and provide, you know, some as good a scenarios as we can for the limited time we have. So that's really our next step. But it's, you know, I think it can't be understated how beneficial it is to have a well-calibrated model, because as Director Kimball said, you know, some of these areas like the Tulare Basin have horrible problems and they don't have a lot of historical data. They don't have a model. Some of them have more than one GSA in the same basin, and it's going to be, you know, a mess in trying to do this job. So we at least are starting with a good starting space. So
yeah, good comments, Tony. Yeah, we probably didn't emphasize, or maybe I didn't emphasize that enough. The advantages of this regional model is we're coordinating with SCV Water upstream for their base flows and simulating changes in the runoff, as that's more important to us than it may be to them. Mound Basin GSA downstream is anxiously awaiting these results. And as Fox Canyon GMA approaches their 5-year update in additional scenarios, they will benefit from the upstream, the best guess of the upstream activities as well. So, you know, there's really some nice benefits of a regional model. And it's the expectation of DWR that these adjacent basins communicate with each other, and we're doing that.
So let me ask you this. So based on our model, we have this amazing tool. Is it going to come to our board that says, these are the 4 suggested models that we run? Or is that coming from our technical subcommittee that's going to decide that and then bring it to our board for us all to decide on? I want to make sure that we're not spinning your wheels and saying, I want 50 different colors, or you know what I mean? 50 different models. I don't think we have time for that. And I appreciate everyone's hard work. I mean, Jason and so forth. I've been on that side before that says, run all of this. So how are we going to do that? Because I want to make sure we're spending our time wisely.
Where's Tony Morgan?
I'm waiting for him.
Yeah, I'm here. I think that the easiest way to think about it is we'll get the 2070 data back from United on the first run, showing the future conditions. That climate scenario is a fairly, depending on how you think of it, conservative, meaning it's more extreme. And we'll see how that fares. If we find out that there's not a lot of bad things likely to happen under that forward extreme scenario, we're in good shape. We'll come back to the board and say, you could implement projects to improve conditions in the basins, or you could not. And it'll be up to you to make that decision. We'll also run the 2030 scenario, which is a little more moderate climate change scenario. And I think of it as more a more likely scenario. And we'll look at that as well and see what the differences are. But once we have those, then we'll come back to you. And you remember, you saw the basin stress test that we rolled out last month at the board meeting, where we are increasing pumping in the basin and seeing what happened to water levels in various wells, where you're going to have a similar type situation when we have the future conditions. You're going to see what's going on in key wells around the basin, and then we'll make the decision of how we're going to set our criteria for MTs and MOs and that kind of thing. We'll have a little more information with which to be able to pull all that information together. So did that help describe the general flow path of the work?
Yes, however, I am sensitive in the fact that we have purchased water. And how does that play into this? Because if you're going to forecast for the future, are we forecasting with none or what? Are you taking out of the number before you do your forecast? I want to know.
Got it. Okay, so the initial run will be without any Article 21 water, just a somewhat baseline condition with climate change factored into it. So we're not going to buy any water in the first model run, and we'll see what it looks like. Then we can come back to you and say, hey, it looks like it would probably be advantageous to buy water and we'll figure out what that recurrence interval looks like, and we'll talk about how much water would have a positive impact that we need to see in the basins. And then we can begin to say, okay, it looks like we need to buy 10,000 acre feet, and we need to buy that every average every 7th year. Well, then we can give that information to Jason. He can implement that in the model, and we'll go from there.
Okay.
But we're not going to do that on the first run. We're going to take a look and see what the basin is without any projects, and not spending any additional money on projects or buying water. And let's just see what the conditions are.
I really would appreciate that, because I don't want to artificially inflate anything.
Yeah, and United's year-to-year activities are simulated in the baseline modeling. So based on how much it rains on any particular year, we've programmed in the criteria for how big the releases are and when they'll be. So our activities are baseline. Additional purchase would be additional waters.
Well, and then also we had Fox Canyon with purchasing water, and then it filtrated down to there. So that's why I want to understand that as well.
So Dan, just to clarify, you're taking into account the normal releases of water stored behind the Santa Felicia Dam?
That's correct. So Dr. Brom-Serkiu is basically scripted what our normal activities would be on how much water comes into the reservoir and what size and the timing of what releases we would commence. So yeah, that's baseline activity for United.
And that's again based on our historical averages?
Correct. That's based on what we normally do, given the amount of winter rainfall.
Thank you.
Can I also ask a question in regards to the flow rate that comes out of the delta and so forth? Does that have any effect into how much water we can release, or the mussels in Lake Piru or anything like that?
I don't think we have the mussel and water quality element integrated, but we are trying to anticipate what DWR can provide. So United has a fairly small allocation. We try to buy state water whenever it's available, up to our 3150 allocation. So that is part of our forward scenarios. Availability, and DWR, Tony, I believe, provides estimates into the future as well. And so we are contemplating what we can purchase and import.
Okay, thank you. Are there any other questions in regards to what we're going to be modeling?
Dan, I just had a question about where are we with feedback with regards to the FERC licensing of Permit Dam, because that might have impacts on flows into Santa Felicia Dam.
More likely outflows, I think, than the inflows.
Well, outflows from Permit into Santa Felicia Dam. I mean, it ties to Kelly's question about the state water project. Through the FERC licensing, there might be flow changes.
At Pyramid, you meaning?
Oh.
Yeah, that impacts Santa Felicia.
So far in the permitting process, there aren't any projected changes. That part is pretty locked in, but you can't tell. I mean, something might happen. But we can provide more of an update on that now, but I don't think we have any knowledge of any changes in the operation that would warrant changing our baseline scenario at this time.
Right,
Good
thanks,
to know.
Tony.
Good to know. Okay, then Tony, Morgan, is there any other next steps with this modeling? We're going to run our baselines. Anything else that our board and our stakeholders here today would need to know?
I think the biggest thing is getting that first future scenario run through United when they're ready to share the outcome of that. And then there'll be a lot of decision points that will branch off of the results from that modeling run.
Okay, and then is that information going to be provided to our technical team that are creating or suggesting the criteria for the 6 deadly sins. I mean, the 6 sustainable measured criterias.
Yeah, we'll come back to you with a presentation similar to what you saw in the basin stress test last month at the board meeting. And so we'll present what's going on with water levels in various representative wells around the basin. And then we'll re-engage heavily in the conversation of what do we do with our sustainable management criteria for water levels, storage, and that kind of thing.
Okay, then expectations for the next board meeting. If any of our wonderful people that are here today want to zoom in for our next board meeting, what would we be talking about?
We're going to talk a little bit more about the basin stress test, a little bit of other information we've teased out of it from last month's presentation. And then we're going to talk a lot about the surface water depletion due to groundwater extraction, that indicator. That'll be the primary focus of it.
Okay. That's a lot of good information. If you want details and get nerdy on water, we're here for you. Lisa, is there anything else on our agenda that we need to go over?
That's it. I think we've covered everything. As always, if anybody has more comments or thoughts after the meeting, please feel free to email Eva. Her email is on the flyer and I can put it in the chat quickly, or even maybe you can just put it there real quickly so everybody has that.
I have the next board meeting at 5 o'clock on January 21st. Is there another meeting before then?
December.
Yeah, December 17th is next Thursday.
Oh, yeah, there we go. Thank you.
I have it on the 17th as well.
All right, well, we have a meeting. This will be discussed on a next meeting of December 17th. And then also save the date for our following one, which is January 21st, and they'll both be at 5 o'clock. Is there anything else in the chat? Perfect. Again, thank you, Jason and Dan and Zach and just everybody in the team, Lisa and Tony for all the great things that you guys are doing. This is a heavy lifting in a quarantined time, so appreciate your thoughts and efforts and all the our directors being on and the stakeholders. Appreciate your time and effort. Is there any other comments or questions before I close our stakeholder meeting? All right, we will see you via Zoom in a week. Thank you so much, you guys. Have a good night.
Good night.
Good night, everyone.
All right.
All right.